Have you ever thought about how vast the universe is, and that you should go out and explore it? In video today, you will journey through many of the known celestial structures in modern astronomy, witnessing a series of beautiful and terrifying sights. I hope this journey brings you a mentally and physically enriching exploration of the cosmos. Your exploration begins in the solar system, extending to the farthest reaches of our current technological grasp. The first stop is your old friend, Mars. Its distinctive reddish hue, due to the iron oxide covering its surface, makes it easily recognizable. It is also one of the most studied celestial bodies in the solar system. Though only half the size of Earth, it has captivated humanity for generations. Rovers like NASA's Opportunity, Curiosity, and Perseverance have sent back invaluable data about its climate and geology. What you see here is a magnificent view of Belva crater, captured by the Perseverance rover's camera. This crater is located within the larger Jezero crater, the primary exploration site for this mission, selected for its potential to preserve evidence of ancient life. Elsewhere, Perseverance has also documented many peculiar rock formations and unusual geological structures. This panoramic image was taken by the Opportunity rover in Greeley Valley, where it spent the Martian southern hemisphere's winter. The surface appears reddish, rocky, and coarse, with tracks left by the rover's passage. These missions are crucial for investigating whether Mars could have harbored life in the past and for preparing for future human landings. Valles Marineris, near the Martian equator, is one of the largest canyon systems in the solar system. It is 10 times longer and 3 times deeper than the Grand Canyon in the United States. In Mars's western hemisphere stands Olympus Mons, the tallest volcano in the solar system. At 22 kilometers high, it is nearly 3 times the height of Mount Everest. This shield volcano was formed by successive lava flows that gradually spread across the Martian surface. Mars has 2 small moons, Phobos and Deimos, named after the sons of the Greek god of war. Phobos, the larger and closer of the two, orbits Mars 3 times in a single Martian day. Deimos orbits farther out, taking about 30 hours to complete one revolution. At Mars's north and south poles, ice caps contain frozen water and solid carbon dioxide, or dry ice. In the Martian summer, some of this ice sublimates into gas, only to freeze again when winter returns. Looking back, you can see our parent star, a G-type yellow dwarf. Thanks to NASA's Solar Dynamics Observatory mission, scientists can observe its activity in high resolution. Our Sun is in the main sequence stage of its life cycle, steadily fusing hydrogen in its core. This stability has allowed life on Earth to thrive for billions of years. The Sun's energy output is nearly constant. While not particularly large on a cosmic scale, it could still hold 1 million planets the size of Earth. Sometimes, solar prominences erupt to astonishing heights, nearly 8 times the diameter of Earth. During periods of peak solar activity, it releases vast amounts of charged particles, creating brilliant auroras in the skies of Earth's poles. Some of the most spectacular solar eruptions even have names, such as the Slingshot Prominence, where solar flares and massive amounts of plasma were observed cascading back to the Sun's surface. Leaving the solar system, you arrive at the Eagle Nebula, an active star-forming region shining in the constellation Serpens, about 7,000 light-years from Earth. Radiation from massive stars creates unique phenomena, such as the famous pillars of creation. This radiation carves out fascinating shapes by eroding gas and dust. These cosmic structures, stretching 4 to 5 light-years, are about 30,000 times the distance from the Earth to the Sun. They are composed of molecular hydrogen and interstellar dust, containing the essential materials for star formation. Behold the Carina Nebula, a cosmic wonder in the constellation Carina, about 7,500 light-years from Earth. These images, captured by the James Webb Space Telescope, reveal intricate details previously hidden deep within the massive gas clouds. Here, young, massive stars are forming, releasing immense energy that sculpts the surrounding gas and dust. Gas jets erupting from specific regions of the nebula originate from intense stellar activity within. This is your first encounter with a black hole. In April 2019, humanity captured the first ever image of a black hole, a groundbreaking achievement in astronomy made possible by the Event Horizon Telescope, an international collaboration. The focus was on the black hole at the center of the galaxy M87, chosen for its relatively clear surroundings. Our own galaxy, the Milky Way, also harbors a supermassive black hole at its center, Sagittarius A*, whose image has also been revealed. The glowing ring around it is the accretion disk, a structure of gas, dust, and other matter swirling at incredible speeds. As light approaches a black hole, its path is bent by the immense curvature of space-time. The event horizon marks the point of no return. Any matter crossing this boundary cannot escape. Within the event horizon lies the singularity, a region where the known laws of physics no longer apply. What happens there remains a mystery. Some theories speculate it may connect to other parts of the universe, or even different universes, but this remains speculative. The largest black holes detected to date include TON 618, the Phoenix A** black hole, and SDSS J0100 plus 2802, each with a mass billions of times that of the Sun. These behemoths at the cores of their galaxies formed in the early universe and can unleash powerful particle jets. Kepler 452b, an exoplanet 1,400 light-years from Earth, is often called Earth 2.0, due to its striking similarities to our planet. It lies within its star's habitable zone, orbiting a Sun-like star with a 385-day year, similar to Earth's. The clouds on Kepler 452b are believed to be thick and foggy, obscuring much of the surface from space. With a mass 5 times that of Earth, it may generate significant internal heat. If it is a terrestrial planet, this heat could trigger intense volcanic activity. If this hypothesis is correct, the planet would be covered in active volcanoes, with rivers of lava and ash plumes soaring into the clouds. The volcanic particles, combined with the thick atmosphere, would scatter light in a unique way, potentially making sunrises and sunsets appear in vivid shades of red. If life exists on Kepler 452b, it would likely be vastly different from life on Earth, truly beyond imagination, yet fascinating to ponder. The high gravity, dim sunlight filtering through thick clouds, and potential volcanic activity would shape the adaptive traits of any life forms. Keplerian luminous pylon, a bioluminescent plant that could grow to extreme heights to absorb the faint sunlight penetrating the atmosphere. The planet's strong gravity would give it a dense, fibrous trunk, and jagged roots would draw nutrients from the volcanic soil. Nebula floater vine, a floating vine made of lightweight tissue, adapted to the planet's thick, humid atmosphere. It would absorb moisture and nutrients directly from the air through spongy aerial roots. Gloom ruminant, a multi-stomached herbivore specialized in digesting the tough vegetation of Kepler 452b. Its skin would be covered in glowing symbiotic moss. Lava titan worm, a giant worm living beneath the volcanic surface, feeding on magma. Its heat-resistant body would glow red, warning off potential predators. Umbromegalyr, a terrestrial creature with disproportionately large ears, evolved to detect ground vibrations. Its vision would be severely limited by the planet's dense fog, so it would navigate by sound. OTS-44 is like a cosmic wanderer, a rogue planet drifting freely in space, untethered to any star. It is surrounded by a protoplanetary disk of gas, dust, and ice, with an estimated mass of about 30 times that of Earth, potentially capable of forming a planetary system. Surprisingly, rogue planets are not rare. In fact, they may outnumber stars in our galaxy. Without the warmth of a nearby star, they are dark and frigid places. However, scientists speculate that some rogue planets with thick atmospheres and internal liquid water could harbor life beneath their surfaces. Gliese 667cc is a fascinating planet. Located about 24 light-years from Earth, it is one of the most promising candidates for a habitable world outside our solar system. Its mass, 4.5 times that of Earth, suggests it may have a suitable rocky composition and conditions similar to our own. Its parent star, Gliese 667c, is a red dwarf, meaning the planet receives dimmer light, and the sky would have a reddish hue. Due to its proximity to its star and potential tidal locking, it might have one hemisphere of scorching heat and another of freezing ice. As a super-Earth, its stronger gravity and greater mass could result in towering mountains and active volcanoes. Under such conditions, imagine the kinds of creatures and vegetation that might evolve on Gliese 667cc. Fluorescent trees, with trunks that glow green in the dark. They don't photosynthesize but extract energy from minerals in the soil. Their light could guide nocturnal animals, helping to spread their seeds. Luminous striders, four-legged creatures with bioluminescent legs used for communication and to light their way in the planet's dark hemisphere. Their dark skin helps them blend in and retain heat, while their large eyes capture faint light. Ephemera striders, with air sacs in their abdomens and long legs, allowing them to briefly float over the rocky terrain. This ability gives them an advantage when exploring or evading predators in a landscape of solid ground and deep valleys. Spiral-tailed probers, with spiral tails that function like antennae, detecting changes in stellar radiation or distant movements. They create vibrations with their tails that can be sensed by others as a warning signal. Bifurcated tongue beasts, adapted to arid regions, using forked tongues to extract moisture from the air. Their bodies are covered in reflective scales that deflect stellar radiation, minimizing water loss. Fur flowers, with glowing flowers growing on their fur to attract insects, which they then consume for nutrients. These are not true flowers but specialized extensions of their skin that are bioluminescent. WASP-12b is a real hot potato. This exoplanet orbits its star at a dangerously close distance, with a surface temperature of a scorching 2,500 degrees Celsius 4,500 degrees Fahrenheit. It absorbs 94% of its star's light, making it one of the darkest known celestial bodies, appearing almost pure black. At such extreme temperatures, it is being slowly devoured by its star, its atmosphere gradually dissipating into space. The star's gravity has also distorted its shape into an ellipsoid, resembling a rugby ball. The Helix Nebula is as beautiful as a great eye. This structure, located in the constellation Aquarius about 650 light-years from Earth, is the remnant of a sun-like star that exhausted its nuclear fuel. Its eye-like appearance has earned it the nickname, the Eye of God. At its core, the star has evolved into a white dwarf, causing the surrounding gas to glow in shades of blue and red. Poltergeist, PSRB 1257+12a, has a cool name. This exoplanet, about 2,300 light-years away, orbits a pulsar. It is one of the smallest exoplanets ever detected, standing out among its much larger counterparts. Furthermore, it was the first exoplanet found orbiting a pulsar, proving that planets can exist in some of the most hostile environments. Due to its proximity to the pulsar, it is constantly bombarded with high-energy radiation, creating extreme environmental conditions where the possibility of life is virtually nil. Comet 67P/Churyumov-Gerasimenko gained global attention in 2014 when the European Space Agency's Rosetta probe successfully entered its orbit and deployed a lander, marking the first time humanity had accomplished such a feat after a decade-long journey through the solar system. The mission finally reached its target. These images were taken with advanced cameras designed to withstand extreme conditions and record intricate details with high precision. On Comet 67P, Rosetta discovered complex organic molecules, including glycine and phosphorus, supporting the theory that comets may have delivered organic compounds to early Earth. In this short video, you can see the comet's surface covered in dust, with cosmic rays streaking through, leaving trails. The Red Ribbon Nebula is also a supernova remnant, a cosmic scar that echoes through time. This stellar remnant tells the story of a massive explosion in the constellation Lupus around the year 1006 AD. It was an exceptionally bright supernova, witnessed by astronomers in China, Japan, Arabia, and Europe. This red stripe is part of the supernova's expanding shockwave, composed of interstellar gas heated and ionized by the explosion. Trace 2b is incredibly dark. This gas giant is considered the darkest exoplanet discovered to date, reflecting less than 1% of the light it receives. The reason for its extreme darkness is still unclear, but scientists speculate that its atmosphere contains elements that absorb light rather than reflect it. Nevertheless, due to its proximity to its star, the trapped heat may cause its atmosphere to emit a faint red glow. You are now witnessing a supernova, one of the most magnificent fireworks in the universe. These violent stellar explosions occur at the end of a massive star's life or in a binary system, releasing enormous amounts of energy. They reach peak brightness within days of the explosion, and if they occur within our galaxy, are sometimes visible to the naked eye. During a supernova, the star's core is extremely compressed, and its atomic structure collapses, potentially leading to the formation of a neutron star or a black hole. Years after the explosion, the remnant material expands outward, forming an ever-growing nebula. A famous example is Cassiopeia A, the remnant of a supernova that exploded in the constellation Cassiopeia about 300 years ago. KOI 4878.01, is this Earth's cousin? Although not yet confirmed, this exoplanet, estimated to be 1,100 light-years away, may be the most Earth-like world discovered so far. With an orbital period of 449 Earth days and a mass greater than Earth's, it would have slightly stronger surface gravity. Furthermore, it orbits its star at a greater distance than Earth does from the Sun. If its atmosphere is rich in greenhouse gases, it might be able to maintain a climate similar to Earth's. In theory, this exoplanet could have vast oceans, frozen polar regions, and lush temperate continents. If KOI 4878.01 is confirmed, such conditions could support some form of life. Though not necessarily, the planet's greater distance from its star might result in dimmer starlight than Earth receives. Fluctuating temperatures, with some areas exposed to intense radiation while others are in deep shadow, combined with high tectonic activity, would shape the evolution of its species. Vivid Spiralis, a low-growing plant with spiral leaves that shimmer with a golden glow in the starlight. Umbro Predator, a predator with pure black skin that absorbs all light, making it appear as a living silhouette. This skin allows it to blend into any dark corner, becoming almost invisible. Even in direct light, it remains hard to spot as it reflects no sheen. Crustacean Carapace, a large, four-legged herbivore with a segmented carapace that deflects light, providing protection from predators. It feeds on the hind leaves of the light-absorbing sawleaf plant and thrives on plains and rolling hills. Crested Glowbeast, a four-legged creature with a luminous crest used for signaling and communication within its group. The intensity of its bioluminescence reflects its emotional state. Pluvial Plume, a mammal with a long tail covered in bioluminescent feathers, which it uses to attract mates. These oversized feathers also help regulate body temperature, dissipating heat in warm climates or providing insulation in cold ones. Inferno Walker, a short, stocky creature inhabiting volcanic regions. Its legs are covered in a natural, ceramic-like protective layer. It can drink boiling water without harm, thanks to the robust resilience of its digestive system. Look, these are the cosmic filaments, the grand skeleton of the universe. These are the largest structures in the cosmos, stretching for hundreds of millions of light-years. Composed of galaxies, gas, and dark matter, they weave an unimaginable cosmic web. In this vast network, galaxies and galaxy clusters are arranged along filaments, leaving enormous empty regions known as cosmic voids. Scientists believe that dark matter constitutes most of the mass in these filaments, providing the gravity that holds them together. The Sombrero Galaxy, a stylish galaxy wearing a large hat. This galaxy in the constellation Virgo is about 28 million light-years away. Its appearance resembles a Mexican sombrero. It is a spiral galaxy with an unusually prominent disk and bulge, which is uncommon in the universe. At its core lies a supermassive black hole with a mass equivalent to 1 billion suns, making it one of the largest black holes detected in the nearby universe. Although it appears relatively small from our perspective, its diameter spans 50,000 light-years, comparable to the Milky Way. The Bubble Nebula, this luminous nebula in the constellation Cassiopeia, has a nearly perfect spherical appearance, like a crystal-clear bubble. At its core, a massive, hot star generates intense stellar winds that drive its gradual expansion. The red, green, and blue hues indicate the presence of hydrogen, oxygen, and sulfur, which glow under the intense energy of the central star. This is called an Einstein ring. This phenomenon, captured by the Hubble Space Telescope, occurs when light from a distant galaxy is bent into a ring by the gravitational influence of a galaxy cluster. This is a direct prediction of Einstein's theory of general relativity, which states that massive objects warp spacetime, thus altering the path of nearby light. V838 Monocerotis, this star's eruption was big news. Located in the constellation Monoceros, it stunned astronomers in 2002 with an unusual outburst. Its brightness increased dramatically, and then gradually faded. It produced a light echo, reflected by surrounding interstellar dust, and the Hubble Space Telescope captured these breathtaking images. Unlike a supernova, this outburst did not destroy the star. Scientists speculate it may have been the result of a stellar merger. This is our Milky Way galaxy, our home. Quite magnificent, isn't it? This vast collection of stars, gas, dust, and dark matter contains about 100 to 400 billion stars. It is a spiral galaxy with a dense, bar-shaped structure of stars at its center, with spiral arms extending outward. Most of the Milky Way's mass is composed of dark matter, an invisible, mysterious substance that neither emits nor absorbs light but exerts a powerful gravitational pull. In about 4 billion years, the Milky Way will collide with the Andromeda Galaxy, merging into a single, likely elliptical galaxy. At night, the Milky Way appears as a glowing band of light, a continuous stream of countless distant stars rather than individual points of light. This is a quasar, one of the brightest beacons in the universe. These extremely bright and distant cosmic phenomena are found at the centers of active galaxies. Their immense energy is derived from supermassive black holes consuming vast amounts of gas and dust. Their accretion disks release powerful radiation. Observing quasars is like looking back in time, as some existed over 10 billion years ago, shortly after the Big Bang. Many of them produce jets of charged particles that shoot out from the black hole's poles at nearly the speed of light. Shown here is a schematic of a blazar, a quasar-like object whose relativistic jet is pointed almost directly at Earth, making it appear exceptionally bright from our perspective. This is our old neighbor, the Andromeda Galaxy, the closest spiral galaxy to the Milky Way, located about 2.5 million light-years away. Its estimated diameter is 220,000 light-years, nearly twice that of our Milky Way. It contains about 1 trillion stars, almost double the number in the Milky Way, boasting a vast stellar population. At the core of the Andromeda Galaxy lies a black hole with a mass of about 100 million times that of the Sun, influencing the arrangement and motion of surrounding stars. A quasi-star, a theoretical behemoth. This is a theoretically existing cosmic giant that would surpass any known star in our universe in size. They are believed to have existed in the early universe, shortly after the Big Bang, when environmental conditions were favorable for their formation. These giant objects may have formed after the collapse of a massive star, with a black hole forming at its core while its outer layers remained intact. As the black hole consumed nearby matter, it would have released immense energy, sustaining the quasi-star for a short period. The Butterfly Nebula is as beautiful as a piece of cosmic art. Its 2 wings extend in opposite directions. This symmetry is caused by the violent ejection of material from the dying star at its center. The core of this nebula is an extremely hot white dwarf, still hidden behind a thick cloud of dust. The Pleiades star cluster, this cluster is 440 light-years away and is known as the Seven Sisters because of its 7 bright stars visible to the naked eye, although it actually contains over 100 stars. Its most prominent stars are hot, young, and massive, including Alcyone, Atlas, Electra, and Maya. It is easily visible without equipment in rural areas far from light pollution, and a telescope can reveal many more stars within the cluster. This is Betelgeuse, which has been expected to explode for years but hasn't. This giant star in the constellation Orion is easily recognizable by its deep orange red hue. It is approaching the end of its life cycle, having exhausted the hydrogen in its core, a process that will eventually lead to a supernova explosion. By volume, it is one of the largest stars in our galaxy, hundreds of times the size of the Sun. Neutron stars, the dense little powerhouses of the universe. As one of the densest objects in the known universe, A neutron star is formed when a medium-mass star exhausts its fuel and ends in a supernova explosion. Although their mass is 1.4 to 2.16 times that of the Sun, their diameter is only about the size of a city, making them incredibly dense. Their density is so high that a teaspoon of neutron star matter would weigh billions of tons on Earth. The magnetic field surrounding these stars can be trillions of times stronger than Earth's. In a binary system, two neutron stars gradually lose orbital energy by emitting gravitational waves. Over time, this energy loss causes them to spiral closer until they eventually collide and merge. This violent event produces an exceptionally bright and easily detectable burst known as a kilonova. The Cat's Eye Nebula. This nebula is known for its complex and symmetrical structure, layered like an intricately carved work of art. It features multiple layers of gaseous material, knots, and patterns resembling delicate shells. Its interior contains dense concentrations of gas, but their exact formation process and role remain a mystery. K2-141b. This star has a fiery temper. This extremely hot and uninhabitable exoplanet is located in the constellation Aquarius, about 200 light-years from Earth. It is a rocky world about the size of Earth, but it orbits its star much more closely, making it a veritable lava planet. K2-141b experiences a rock cycle where minerals evaporated from its molten surface rise into the atmosphere, cool down, and then fall back to the surface as solid rock rain. One side of it is permanently facing its star, creating a hemisphere of extreme heat, while the other side is perpetually shrouded in darkness and cold. Hickson Compact Group 44. This group of galaxies is really huddled together for warmth. This galaxy group is about 300 million light-years from Earth and contains elliptical, spiral, and irregular galaxies. They are unusually close to each other on a cosmic scale, and having such diversity in such a compact space is uncommon. Their close proximity has triggered gravitational interactions, distorting their shapes and causing them to exchange stellar material. As a result, they are likely to merge into a single giant elliptical galaxy within the next billion years, forming a massive celestial structure. J1407b. This planet's hula hoop is seriously huge. Discovered in the constellation Centaurus, it is notable for its enormous ring system, which is about 200 times the size of Saturn's rings. If it were in Saturn's current position, its rings would be clearly visible from Earth, appearing much larger than the full moon in the night sky. TRAPPIST-1. This 7-dwarf planetary system has one star with 7 planets. It is located in the constellation Aquarius and has at least 7 planets orbiting an ultra-cool dwarf star. All its planets are rocky, which is an unusual feature as most planetary systems typically contain a mix of gas giants and terrestrial planets. TRAPPIST-1e, TRAPPIST-1f, and TRAPPIST-1g are located in the star's habitable zone, where temperature conditions might allow for the existence of liquid water. Due to the star's relatively low temperature and energy output, these planets do not experience extreme heat despite their close orbits. When you see Stephenson 2-18, you are looking at one of the largest stars observed to date. This guy is a true giant among stars. It is a massive red supergiant, so enormous that it surpasses the famous Scuti. Its radius is estimated to be about 2,000 times that of the Sun. If placed at the center of our solar system, it would extend all the way to Saturn's orbit. At some point, it is expected to explode as a supernova, leaving behind a stellar remnant, possibly a neutron star or a black hole. HD 189733b. Beneath this planet's striking blue exterior lie extreme conditions that fascinate astronomers. Don't be fooled by its pretty blue appearance, it rains glass. Tidally locked, with one side always facing its star, the huge temperature difference between day and night creates powerful winds that try to balance the heat. Its atmosphere contains silicate particles that vaporize in the scorching heat of the day, forming tiny droplets in the clouds. These droplets are carried by supersonic winds to the permanent night side, where they condense and fall as molten glass rain. This is Pandora's cluster, not the Pandora from Avatar. 4 galaxy clusters have been colliding and merging for over 350 million years to form this chaotic and complex structure. It is notable for its unusual distribution of dark matter, which is spread throughout the cluster and appears in some unexpected locations. Through gravitational lensing, it acts as a cosmic magnifying glass, revealing galaxies that formed shortly after the Big Bang. This is an imagined wormhole. These theoretical tunnels connecting distant points in spacetime are permitted by Einstein's theory of general relativity, but whether they actually exist is still uncertain. To keep a wormhole stable would require exotic matter, a substance with properties that violate the known laws of physics. Assuming a traversable and stable wormhole could be created, from the outside, it would appear as a distortion in space. Looking directly at it, we would see a sphere reflecting a view of a distant region of the universe, like a window to another place or time. Approaching and peering inside, it would look like a tunnel, but not of physical space, but of compressed spacetime itself. Astronomers have examined images of galaxies and stars for distortions that might hint at the existence of wormholes, but so far, all observed anomalies that were suspected to be related to wormholes can be explained by the effects of black holes or other massive objects. R136A1, this star is blindingly bright. It is located deep within the Large Magellanic Cloud and is known for its immense size and astonishing luminosity. Its mass is nearly 197 times that of the Sun, which has prompted scientists to rethink theories of star formation, challenging the previously thought upper limit of 150 solar masses. It is 4.7 million times brighter than the Sun, radiating as much energy in just 4 seconds as the Sun produces in a full year. However, its existence is fleeting, lasting only a few million years before it collapses, far shorter than the Sun's 10 billion-year lifespan. Tabby's star, this star really blinks. Located about 1,500 light-years away, it became famous in 2015 for its unusual brightness fluctuations. It experiences irregular dips in brightness of up to 22%, which is an anomaly for such a star. Most stars' brightness changes are caused by orbiting planets, but the fluctuations of Tabby's star are too irregular to fit this pattern. With no clear explanation, some have proposed that this phenomenon might be related to some kind of alien megastructure, such as a Dyson sphere under construction. Another theory suggests that dust clouds in an irregular orbit periodically block some of the star's light. An antimatter star, if it truly exists, would be a game-changer. This is a theoretical star composed mainly of antimatter rather than ordinary matter. In theory, it would shine and generate heat like other stars, but its interaction with the surrounding matter-based universe would trigger explosive reactions. To date, no direct evidence of antimatter stars has been found, but if they exist, they would completely change our understanding of the universe. Their discovery would indicate that antimatter can exist in a stable form, or that some regions of the universe are composed entirely of antimatter. Such a breakthrough could reshape our understanding of physics and technology, and could pave the way for antimatter as an energy source or propulsion method. The Cygnus Loop, a wisp of gauze in the cosmos. This giant cloud hidden in the depths of space was born from a supernova explosion that lit up the sky 10,000 to 20,000 years ago. It spans 120 light-years and covers an area equivalent to 6 full moons as seen from Earth. Part of this structure includes the Veil Nebula, a region characterized by its intricate filaments of ionized gas and dust. It is like a flowing tapestry, with vibrant colors originating from the light emitted by chemical elements interacting with radiation. A hypernova, the ultimate supernova. These cataclysmic events release up to 100 times more energy than a typical supernova, unleashing immense radiation in just a few seconds. A hypernova occurs when a star with more than 30 times the mass of the Sun collapses at the end of its life, forming a black hole at its core. The ejected energy throws out matter and interstellar gas at extremely high speeds, reshaping the space within a radius of tens of light-years and potentially destroying nearby planets. Although rare in the universe, hypernovae play a crucial role in cosmic chemistry. They produce and scatter heavy elements like iron, nickel, and gold, enriching the interstellar medium. Omega Centauri Globular Cluster, a dazzling array of stars. For those with trypophobia, beware. As one of the largest globular clusters, it contains about 10 million stars. Its age is estimated to be about 12 billion years, making it one of the oldest objects in the Milky Way, a relic of the early universe. Its brightness makes it visible without a telescope. Under clear conditions, it appears as a hazy patch of light in the southern sky. In the Omega Centauri cluster, stars are much more densely packed than in our region of space, creating an environment vastly different from our own. The Large Magellanic Cloud, the Milky Way's little brother next door. This galaxy looks like a faint mist and is visible to the naked eye in the southern hemisphere, located in the constellations Dorado and Mensa. It is 160,000 light-years away, considered relatively close as a satellite galaxy of the Milky Way. Inside it is the famous Tarantula Nebula, an active star-forming region that nurtures massive stars like our 136A1. This nebula is so bright that if it were placed at the same distance as the Orion Nebula, it would cast shadows on Earth's surface. IC 1101, the undisputed behemoth galaxy of the universe. This supergiant elliptical galaxy, a billion light-years away, fascinates astronomers as one of the largest galaxies ever discovered. It is estimated to contain about 100 trillion stars, far surpassing the Milky Way's 200 to 400 billion stars. Its diameter is 6 million light-years, about 60 times that of our Milky Way. At its core lies a supermassive black hole, one of the largest in the known universe. The KBC Void, a cosmic region so empty you could race horses in it. It is considered one of the largest voids in the universe, with a volume large enough to contain 1 trillion solar systems. Although called a void, the region still contains galaxies, dark matter, and interstellar gas, but its density is far lower than in other parts of the universe. Some theories suggest that the Milky Way and the local group may be located near the center of this void, which could affect our cosmological observations. The existence of such a low-density region nearby challenges the cosmological principle, which assumes the universe is homogeneous on large scales. The Black Eye Galaxy, M64, this galaxy has some serious dark circles. It exhibits a rare phenomenon, two gas disks of comparable mass rotating in opposite directions, suggesting a past interaction with another galaxy. Its unique black eye appearance comes from a massive dark dust lane that crosses its core, partially obscuring the starlight. A gamma-ray burst, this is like a cosmic lightning bolt, with explosive energy and immense power. This brief but intense burst releases electromagnetic radiation in the form of gamma rays, the highest energy light known. It occurs when two neutron stars merge, or when a neutron star collides with a black hole, and during the collapse of a massive star. Most gamma-ray bursts originate in distant galaxies, meaning that by the time we detect them, the event has long since passed. Some scientists speculate that a nearby gamma-ray burst millions of years ago could have triggered a mass extinction by damaging Earth's ozone layer. Longer-duration gamma-ray bursts may occur within rapidly rotating stars and young galaxies. When the star's core collapses under its own gravity, a black hole is formed, and matter falling toward the black hole is funneled toward the poles, creating high-energy jets traveling at the speed of light. The Rho-Ophiuchi Cloud Complex, the cradle of stars, a place of new beginnings. This region in the constellation Ophiuchus is about 460 light-years from Earth, and is one of the closest star-forming regions to us. Here, clouds of gas and dust collapse under gravity, forming dense cores that eventually ignite into new stars. The Crab Nebula, the remnants of a cosmic explosion from over 1,000 years ago, are still visible today. This supernova remnant was born from a stellar explosion in 1054 AD, recorded by Chinese and Arab astronomers. At its core is the Crab Pulsar, a rapidly rotating neutron star that emits a stream of particles known as a pulsar wind. The Horsehead Nebula, a dark horse in the cosmos, its silhouette is stunning. Its dark profile is created by a dense cloud of gas and dust that blocks the light from background stars. It forms a striking silhouette against the backdrop of the Orion Nebula. Its visibility is thanks to the illumination of a massive star located just outside the nebula's main body, which lights up the surrounding gas. As part of a vast molecular cloud and nebula system in Orion, it belongs to a complex that includes the Orion Nebula and the Flame Nebula. Brown dwarfs, they are jokingly called failed stars. They form similarly to stars but lack the mass to sustain hydrogen fusion, making them more like giant planets. Due to their extremely low luminosity, brown dwarfs radiate heat rather than visible light, making them difficult to detect with traditional telescopes. They gradually cool over billions of years, allowing them to exist for an extremely long time. The Ring Nebula, M57, a glimpse into the Sun's future. When a Sun-like star reaches the end of its life, it casts off its outer layers, forming a glowing ring of gas. At its center is a white dwarf, whose ultraviolet radiation illuminates the surrounding nebula. This event foreshadows what will happen in about 5 billion years when the Sun exhausts its nuclear fuel. GJ1214b, this candidate for a water world is quite mysterious. It is classified as a super-Earth, orbiting a red dwarf about 40 light-years from Earth. It has an atmosphere rich in water vapor, methane, and thick clouds, and is thought to be a possible ocean world. Nearly 75% of its mass is composed of water in various forms, though this has not been confirmed. Further research is needed to determine if it has a liquid surface or if its water exists in other forms. 47 Ursae Majoris c. This exoplanet orbits the star 47 Ursae Majoris, located in the constellation Ursa Major about 46 light-years from Earth. It is a gas giant similar in size and composition to Jupiter, but it orbits its parent star at a greater distance. As a giant gas world far from its Sun, its atmosphere is likely composed of hydrogen, helium, and massive storms. Its parent star system is estimated to be about 6 billion years old, making it much older than our solar system. The Whirlpool Galaxy, M51, a classic spiral galaxy. Located in the constellation Canes Venatici, about 23 million light-years from Earth, it is easily observable from our planet. Look at its beautiful spiral arms. It contains black holes and neutron stars that release energy as they consume matter from their companion stars. A smaller galaxy, NGC 5195, is connected to the edge of one of its spiral arms, and the two are interacting gravitationally, triggering intense star formation. The Fishhead Nebula, IC 1795, like many emission nebulae, this region is home to many young, forming stars. Its reddish hue makes it look like the head of a cosmic fish. Its distinctive color comes from abundant ionized hydrogen, which emits red light when electrons recombine. It also contains small traces of oxygen and sulfur. Stephan's Quintet, 5 galaxies dancing a group dance. What a spectacular sight! This compact group of galaxies consists of 5 galaxies, 4 of which are in a state of intense interaction, producing extraordinary astronomical phenomena. They are caught in a gravitational dance, with tidal forces distorting their structures and triggering star formation within their spiral arms. The Orion Nebula, M42, this nebula is easily visible to the naked eye in the constellation Orion, spanning a vast 24 light-years. You can see it on a winter night. It's not that far from us. Inside it is the famous Trapezium cluster, a group of young, hot stars that illuminate the surrounding gas. It is essentially a stellar nursery, where hydrogen gas collapses under gravity to give birth to new stars. M82, Cigar Galaxy, an irregular galaxy in the constellation Ursa Major, forming stars at an astonishing rate. It's a stellar factory. Due to gravitational interactions with a neighboring galaxy, it is forming stars at an unusually high rate. This accelerated star birth process has produced powerful stellar winds and frequent supernova explosions. At its core, a massive superwind has formed and extends outward. Heated dust from young stars radiates strongly in the infrared, making M82 exceptionally bright. Binary star systems, 2 stars orbiting a common center of mass due to their mutual gravitational pull. This cosmic duo is quite common. This phenomenon can be observed in at least half of the stars in the Milky Way. These concentric ripples represent gravitational waves, traveling through space at the speed of light. As the stars get closer, the frequency and amplitude of these waves increase, especially in tight orbital configurations. In such systems, the stars can be so close that the outer material may be transferred from one star to the other. The Twin Jet Nebula, its bipolar shape, with 2 opposing lobes, is due to the presence of a star in a binary system at its center. It looks like a cosmic hourglass or butterfly wings. A spiral jet of gas extends from its core, passing through the lobes and being pushed in opposite directions by gravitational interactions. Kepler-22b, this planet in the constellation Cygnus, is about 600 light-years away and was one of the first exoplanets discovered in its star's habitable zone. Will this super-Earth hold any surprises? Its radius is 2.4 times that of Earth, and this super-Earth may have a thick atmosphere capable of maintaining liquid water and supporting complex climate cycles. Its parent star, Kepler-22, is a yellow dwarf similar to the Sun but slightly smaller and cooler, suggesting the planet may have a moderate temperature. As a large rocky planet, some theories suggest it may have mountains and active geology, similar to certain landforms on Earth. And now, for the one and only world confirmed to harbor life, located in the habitable zone of our solar system, our home, Earth. Here, conditions allow for the existence of liquid water. From space, it appears as a striking blue sphere due to its vast oceans and the scattering of light in its atmosphere, a unique phenomenon in the solar system. Over more than 4.5 billion years, its climate, geology, and atmosphere have evolved in extraordinary ways, creating a complex environment that has fostered immense biodiversity. Earth has gone through various geological eras, from its volcanic origins to ice ages, each shaping its surface and influencing the evolution of life. This planet is extraordinary because it has the perfect combination of conditions: the optimal distance from the Sun, an oxygen-rich atmosphere, liquid water, a protective magnetic field, and a diverse chemical composition, all of which have contributed to the emergence of complex life. To date, it remains the most unique planet in the universe. Well, your amazing journey through the universe has come to an end. You have traveled through a cosmos full of wonders. Perhaps one day, when science fiction becomes reality, such long-distance voyages will be possible. I hope this journey brings you sweet dreams. Good night.